So here we are, lesson 13.1. I'm going to run through the preview of this lesson. And let's see here.
What I want to do in this video is talk about the two main ways that triangles are categorized. The first way is based on whether or not the triangle has equal sides, or at least a few equal sides, and the other way is based on the measure of the angles of the triangle. So the first categorization right here, and all of these are based on whether or not the triangle has equal sides, is scalene. And a scalene triangle is a triangle where none of the sides are equal. So for example, if I have a triangle like this, where this side has length 3, this side has length 4, and this side has length 5, and this side has length 5, then this is going to be a scalene triangle. None of the sides have an equal length. Now, an isosceles triangle is a triangle where at least two of the sides have equal lengths. So, for example, this would be an isosceles triangle. Maybe this has length 3, this has length 3, and this has length 2. Notice, this side and this side are equal, so it meets the constraint of at least two of the three sides have the same length. Now, an equilateral triangle, you might imagine, and you'd be right, is a triangle where all three sides have the same length. So, for example, this would be an equilateral triangle, and let's say that this has side 2, 2, and 2. Or if I have a triangle like this, where it's 3, 3, and 3. Any triangle where all three sides have the same length is going to be equilateral. Now you might say, well, Sal, didn't you just say that an isosceles triangle is a triangle that has at least two sides being equal? Wouldn't an equilateral triangle be a special case of an isosceles triangle? And I would say, yes, you are absolutely right. An equilateral triangle has all three sides equal, so it meets the constraints for an isosceles. So by that definition, all equilateral triangles are also isosceles triangles, but not all isosceles triangles are equilateral. So for example, this one right over here, this isosceles triangle, clearly not equilateral. All three sides are not the same, only two are. But both of these equilateral triangles meet the constraint that at least two of the sides are equal. Now down here, we're going to classify based on angles. An acute triangle is a triangle where all of the angles are less than 90 degrees. So for example, a triangle like, this, maybe this is 60. Let me draw a little bit bigger so I can draw the angle measures. So a triangle, it's a little bit less. I want to make it a little bit more obvious. So let's say a triangle like this. If this angle is 60 degrees, maybe this one right over here is 59 degrees, and then this angle right over here is 61 degrees. Notice they all add up to 180 degrees. This would be an acute triangle. Notice all of the angles are less than 90 degrees. So less than 90 degree angles for all of them. A right triangle is a triangle that has one angle that is exactly 90 degrees. So for example, this right over here would be a right triangle. Maybe this angle or this angle is the one that's 90 degrees. And the normal way that this is specified, people wouldn't just do the traditional angle measure and write 90 degrees here. They would normally they would draw the angle like this. They would put a little, I guess you could, the edge of a box looking thing. And that tells you that this angle right over here is 90 degrees. And because this triangle has a 90 degree angle, and it can only have one 90 degree angle, this is a right triangle. So that is equal to 90 degrees. Now you could imagine an obtuse triangle based on the idea that an obtuse angle is larger than 90 degrees. An obtuse triangle is a triangle that has one angle that is larger than 90 degrees. So let's say that you have a triangle that looks like this. A triangle that looks something like this. Maybe This is 120 degrees. And then let's see, let me make sure that this would make sense. Maybe this is 25 degrees, and maybe this is 30, or maybe that is 35 degrees. This is 25 degrees. Notice they still add up to 180, or at least they should. 25 plus 35 is 60, plus 120 is 180 degrees. But the important point here is that we have an angle that is larger, that is greater than 90 degrees. Now you might be asking yourself, hey Sal, can a triangle be multiple of these things? Can it be a right scalene triangle? Absolutely, you could have a right scalene triangle. In this situation right over here, actually a 3, 4, 5 triangle, a triangle that has lengths of 3, 4, and 5 actually is a right triangle. And this right over here would be a 90-degree angle. You can have an equilateral acute angle, acute triangle. In fact, by all equilateral triangles, because all of the angles are exactly 60 degrees, all equilateral triangles are actually acute. So there's multiple combinations that you can have between these situations and these situations right over here.
So let's look at some examples from our textbook. We've got identify equilateral isosceles and scalene triangles. So clearly you can see this first one here is the equilateral with the 3 equal sides and the 3 equal angles. This indicator here tells you that this side is equivalent to this side and this side, or congruent. Now an isosceles triangle, in triangle DEF, 2 sides are of equal length. It is an isosceles triangle. So DE, line segment DE is equivalent to line segment DF. They are both 2 inches. And then this angle here and this angle here are equal to each other. In this scalene triangle, okay, remember a scalene, I think of everyone stepping on a scale, you get a lot of different weights, especially now with this homebound instruction. I feel like all I do is eat all day. So in the scalene triangle, GHI, so GHI, I like to follow the letters of the vertices of the triangle as they name it. The 3 sides have different lengths. It is a scalene triangle, so 3 different lengths. Clearly this is 2, this is 3, and this is 4. And finally, the right triangle, identify right obtuse acute angles. That helps you specify what type of triangle it is. You can classify triangles by the measures of their angles. So in triangle PQR, R is at a right angle. So right here is a 90-degree angle. So triangle PQR is a right triangle because it has that right angle, and then this symbol helps you remember that it is 90 degrees. Excuse me, there's one more, I think, the acute triangle. Triangle XYZ, the measures of all the angles are acute or less than 90. So this is an acute triangle. So 3 angles less than 90 degrees. By the way, it's impossible to have a triangle with more than one obtuse angle. And here's another quick video of me solving some problems. Hey mathematicians, this question says, which of these triangles is equilateral, isosceles, or scalene? Use the centimeter ruler to find out. So we're going to do several examples here of types of triangles. So when I used my centimeter ruler to measure this side, I got a total of 3 centimeters. And when I measured AC, I got 2 cm. And when I measured AB, I got a distance of 2 cm as well. So if AB is 2 and BC is 3 and AC is 2, then this one fits the definition for an isosceles triangle. Okay, so we're going to look at number 2 here from our textbook. And it says triangle DEF is what kind of triangle? So we got DEF. Now, when I'm acting like a mechanic and you look at a car and it's broken down, you're trying to figure out how to fix it and what tools you need to fix it, you could think you could use a protractor and a ruler to help you solve this problem. So once I took out those tools, I measured some angles. I measured this angle, and this angle. And they were all the same. They all equaled 60 degrees. We know the interior angles of a triangle always add up to 180. And I also, on my protractor, I had a ruler. So I measured FD, DE, and FE. And as you can imagine, all 3 of those sides were congruent. They were equal to one another. So congruent, again, that means the same size and shape. So all 3 of these sides were congruent, were equal to one another. And when I measured them, they actually all came out to be 3 centimeters. 3 centimeters, 3 centimeters. And all the angles were 60 degrees, as I previously mentioned. So based on those rules there, we know that equilateral triangles have equal angles and equal sides. Therefore, we could say in no uncertain terms that this triangle, DEF, is an equilateral triangle. Hey, mathematicians, we're looking at another triangle here. Triangle GHI is what kind of a triangle? GHI. So looking at this, GH, you've got to measure this side. HI, you've got to measure this side high. And GI, this side over here. So it's pretty clear, it's pretty evident that these 3 side lengths are different. So I'm going to grab my ruler and just check that. So I started on the shortest side, and this side here was 2 centimeters. Next, I measured Iggy, this side over here. We're going to call him Iggy, IG. And when I measured IG or GI, they're going to call it GI. So when I measured GI, I actually got a measurement of 4 cm. And then this HI, high side over here on the bottom, that was the longest side at 5 cm. So just plug in what I figured out. And remember, when you're doing the guided practice, they put the units in there for you, but you want to remember when you're practicing independently not to forget to label which unit of measurement you use to measure your sides. In this case, we use centimeters. So clearly, based on the 3 different angle lengths and the side lengths, we can determine that this particular triangle is scalene. So time to practice, students. Complete the reading in the textbook, pages 212 to 216, and then the workbook, pages 163 and 164, are a great opportunity for you to practice.